Okay, today it is Unit 11, Lesson 2. We're talking about change of base. All right, so these are bases that are being put to a power. Hopefully you can find this. I'm going to ask you to show me that you're on the right slide in just a minute. It's the second slide of Unit 11, Lesson 2. Okay, and I know you know everything to the 0 power is equal to 1, 1, 1, 1, 1, 1. It's not 0. That's a really common mistake, but I want to make sure everybody gets that. It's okay. You're human. So 2 to the first is 2. 2 to the second is 4. 2 to the third is 4 times 2, which makes 8. How many of you already had 2 to the third memorized? You get that one. Okay, good. We just need you to get it memorized all the way up through 2 to the fifth. So when you see 2 to the fourth, you should be able to go 16, and 2 to the fifth, you should be able to 32. Can you multiply it up? Yeah, but it's going to be harder for you if you don't have it memorized. It's sort of like you can figure out what your neighbor's name is by looking them up in the phone book, but it's a pain in the butt. It's better to just know their name. Okay, so we need to know them up to the stars. You do not need to know 2 to the 6th. It's obviously pretty easy to do. You can multiply 32 times 2 again and get 64, but you're going to expect it to know up to 2 to the 5th. Okay, the 3s. 3 to the 1 is 3, 3 to the second is 9, 3 to the third is 27. Now, hopefully those 3 came easy for you. But this next one's kind of powerful because it's common. 3 to the fourth is? And why is 81 important? It's also 9 squared. Now think about this. 3 to the fourth also means 3 times 3 times 3 times 3. Get how it's 9 times 9, really? That makes sense? Okay. 4 to the third. Well, let's start with the earlier ones. 4 to the 1 is 4. 4 to the second is 16. 4 to the third is 16 times 4, 64. That one comes up a lot. Down here, this one was 64 that I crossed off and said you didn't have to know. All right, I do not expect you to know 4 to the fourth. And I realize we don't have that much time today, so we're not going to fart around with some of the ones we don't know. All right, so this one's 25. This one, anybody have it memorized? 125. I want you all to be able to do that, like, boom, right off the top of your head. I'm going to ask you a few of them later on today and see if any of them stuck. 5 to the third is 125. And it makes some sense because it's, I don't know, there's actually a kind of a cool pattern you can do for this. But again, I don't have time to delve into it right now. This one's 36. And then 6 to the third is, oh, wait, we don't have to know that one, thankfully, because I don't know that one. I was going to have to multiply it out. I think it was 198. But anyway, and then 7 squared is 49, and that's as far as you'd have to know. Those are pretty easy. Hopefully you already have. 8 squared is 64. 9 squared is 81. Those should be easy, right? So I think the only ones you really should be worried about at all, because you probably didn't know them coming in today, except for a few of you, that one, definitely that one. Not many people knew that one. And I bet you these 2 are ones that people probably didn't know off the top of their head. So the ones I circled in green there, you better memorize those for your next test. And the assignment today would be handy if you knew them as well. Sorry, I'm going to shut this off. It's my accountant calling. Okay, so, yeah, insurance. So this 3 to the x and 3 to the 8th, this is our first problem that we actually have to do. And it's the same base as each other. And that makes it super simple. Really, just think about it. 3 to the what is the same as 3 to the 8th? 3 to the 8th. And therefore, what's x got to equal? 8. So if you get the bases the same as like these are, then this just equals that. That's a rule in math. If the bases are the same, the exponents have to be equal. If you've got an equation. Okay. In an equation where you have the base the same on this side and this side, then that has to equal that. All right. So we use that in problems like this, where we force the bases to be the same, and then the powers will have to equal each other. Everybody get on this slide and turn it my way so I know that you're in the right spot with me. Still waiting for a few people. Rápido, por favor. All right. Good, thank you. All right. So, 8 to the what equals 4 is the question. Doesn't just come to you right away, does it? 8 to the is 4. What the heck? 8 to the something is 4? Yeah, it actually works. Okay. So, I can show you how to solve this by making the bases the same. Now I can't change this 8 into 4 to the something, because 4 to the something doesn't equal 8 unless you're talking fractions and you don't know how to do fraction exponents yet. But 4 to the something makes 8 isn't going to work. So how about if I make both of them have a base of 2? Now this is a really important time as you're learning these. You have to understand what's going on here. Would you agree that I have not kept the problem the same? So I haven't done, this isn't legal. I can't do that. If I'm going to substitute something in for the 4, it has to equal 4. That's the rules in math. You can't take out 1/2 and put in 1/3. They're not the same thing. But if I'm going to take the 4 out and put in a 2, I can put in a 2 squared, and that's equal to 4. That's legal, right? And if I'm going to take out this 8 to the x and put in something else, it has to be equal to an 8 to the x. So I don't know what to put, but I know I have to put it to the x. That has to equal 8. So ask yourself, what could I put here that will equal 8 and yet has a base of 2? That way the bases will be the same as each other, right? What's it got to be? 2 to the third. That's where you're supposed to have that memorized. 2 to the third is 8. See how that would be handy if you had that memorized? Okay. Now that the bases are the same, you're not done, but you got an easy problem left. This has to equal this. Remember how I said if the bases are the same, that the exponents would have to be equal to each other? That has to equal that. And what do you do when you have a power to a power? Do you add them or multiply them? Multiply them. So that's 3x equals 2. And from there, you just have to divide both sides by 3. Yes, this is higher algebra. It's supposed to be higher than algebra. So it is a lot of work. You're right. A lot of steps. In fact, but to be honest, okay, really, how many steps was that? I had to do 2 little steps here to get 8 changed into this and the 4 changed into that. So that's 2 steps. Then I had to set these equal to each other. That's the 3rd step. And then I had to solve that equation. 3 steps before solving the equation. In pre-calc, there's typically 6 steps before you solve the equation. So it gets harder and harder. But it's not impossible. It's just using the same rules, same basics. All right. Now, I know this is a little harder. I warned you, this is a little harder lesson than before. All right, so now this one, again, it does not just jump right out at me. I have to think to myself, okay, if I have to get these things to be the same base, I got to rewrite this and rewrite this. And I have to keep them the same. I can't just change the 32 to a 2. 32 and 2 are not the same thing. But 2 to the something is the same thing. 2 to the what? Maybe you have to look back at your other chart. Yes? 2 to the 4th is 16. You're close. 5th. 2 to the 5th is 32. So that I can substitute in. That's okay. That's legal. All right, and then I remember, got to bring down the x. See how this is setting up? Now I got to go to the other side and get this 1/4, and I can't just write anything I want. I have to make something equal to 1/4. So it's 2 to the something is going to equal 1/4. This is going to blow some minds out there. Would you agree that 2 to the second gets you kind of close because at least it's a 4? Then how do I make it 1/4? Negative 2. 2 to the negative 2 is 1/4. All right, we need to talk about those kind of negative exponents a little bit because I think that's a new thing for a lot of you, and that's what's going to trip you up. Yes, sir?
Can I times both sides by 8 so I'll get like 50 or 1? So.
Where do you want to times it by 8? You want to times this by 8 and times this by 8? Okay, but here's the thing. You can't multiply that 32 by 8 because it's to a power. So that wouldn't work. You can multiply the right side by, well, you can multiply both sides by 8. But what I'm trying to say is you're not going to go 8 times 32.
Yeah, but that would be 2 to the power of 3 plus 2 to the power of 5x.
Okay, I understand, but what you're not understanding is you can't multiply the 8 times the 32 because it's to a power right now. It's like saying, how can I say this? Like 5 to the second. And let's say I want to times it by 5. I can't just times the 5 by the 5 and make it 25 to the second. That's not the same thing. I'll give you even easier numbers for you. Let's say it was 2 to the third, and I wanted to multiply it by 2. Actually, doubling is not going to work. This doesn't work well with the 3's. 5 times 2 to the third. There we go.
Well, but 32 is 2.
All right. I don't want to argue with you. I've answered your question. No, you can't multiply both sides by 8. It won't work. You can multiply both sides by 8. That's legal, and that's fine. But you can't multiply the 8 times the 32 because it's got the exponent of x on it. So you have to trust me, and you could do it. How about this? You try to solve it that way and see if you come up with the right answer. And the way you can know you have the right answer is if when you stick it in for x, it actually works. All right, so I'm backing up here a bit to show you where I was. I like the idea of a new way to do it. I do. It's just I'm telling you that you're going to find out that one won't work. Okay, so back to this. This was the part that most of you would have had your mind explode on right there. Okay, once I get it this far, it's easy, because see, watch. The 2's are equal, and if the bases are equal, it's just 5x equals negative 2. Very simple little equation to solve there, and divide both sides by 5, and the answer is negative 2/5. And it will be easy from there. But the hard part for you was to get 1/4 to be 2 to the negative 2. So let me go off to the side for a second here, and I want you to add some paper in. Everybody add in a blank piece of paper so that you have room in your notes to do some practice on this. We got to do a bunch of things to the negative power so that those don't feel foreign to you. They feel easy. All right? We have to both be able to handle negative powers, and we have to be able to handle fraction powers. So here's the ones you need to know. If I do fraction powers, that means the bottom number is telling you which square root or cube root or whatever it is. So 9 to the 1/2 power, you should be able to go, oh, you're asking me what the square root of 9 is, which is what? 3. So would you please do this one for me? Say it. 5. Square root of 25 is what I really asked you. You get that? Okay, then do you get what a cube root is? To the 1/3 power. If I say 8 to the 1/3, what is it? 2. Because 2 times 2 times 2 makes 8. All right? So what is 27 to the 1/3 power? 3, because 3 times 3 times 3 makes 27. That's fraction powers. Now let me change the fraction power just a little bit. See if hopefully your head doesn't explode. To the 2/3 power. Do you get what I just did was 2 parts? There's still the root. The roots go on the bottom, and I'm going to say this dumb little saying because it helps you remember it, because later you're going to be like, okay, it's fraction. What do? The roots are on the bottom. Isn't that true in most plants? Also true in fraction exponents. The root part is on the bottom. So you just take the root of it, and then once I'm done with that, I've taken the root and I've done that already, then I just have to square it. That 2 is just a normal power. And this is the root. So do the root first. Square root of 27, or sorry, cube root of 27, get the x off of there, is, what's cube root of 27? 3, and then square it. So the answer is 9. All right, I don't expect you to be perfect at fraction powers, but you have to at least handle a few of them. So I'm going to go back to the simpler one. 144, and I do this to it. What's that? 12. Would you agree that that's the same thing then as saying 12 to the 1? 12 to the 1 power is the same as 144 to the 1/2? All right. Okay, so how about this? 64 to to the negative 1. There is no root, Mr. Server. There's no denominator. The roots are on the bottom. There's no root. Okay, there's no root, but there's still two parts. The first part is you put it to the 1 power, and that's just 64. Then you put it to a negative, and what does that do to it? 1 over it. Not opposite, 1 over it. The answer is 1 over 64. All right, so there's all kinds of different powers you have to understand here. I'm going to give you a few more. 49, I'll just keep this one simple, to the negative 1. There's two parts. 49 to the 1. And then what's that mean? Flip. Okay, 49 to the 1 is, and then flip it, 1/49. Yes?
Now, if you had 49 to like the negative second, would it just be like...
It's got two parts. Wait, let's do it. 49 to the negative second was your question, right? It's got two parts. Let's do the squaring first. I got to do 49 squared. That sucks. How about if I change it to 9 to the negative second? Now I can square it easier. Is that okay? 9, and then I square it, which is this is the normal part of the power. So 9 squared is 81, and then I flip it. 1 over 81. If you can get the powers as separate little steps, then this kind of question isn't even that hard. All separate steps. That part is the root. Roots are on the bottom. That part is flip it. And this part is the normal power. So in this case, always do the roots first too, because you want to make them smaller first before you make them bigger and flip and stuff. Okay, so the cube root of 27 is 3. Then I can flip it if I want to, and then put it to the first power. So this was a 3, except I got to flip it. 1 over 3rd, and then I got to put it to the first power, but 1 over 3 to the first power is just 1 over 3. So the answer is 1 over 3. 3 separate little steps. You take the right root of it, the third root in this case, which means what times what times what makes 27. Then you flip it. All right, so you got to try a few. Ready? I want you to turn them my way once you've got them. Do you notice that none of my answers have ever come out negative? Even though the powers have negatives, the answers don't come out negative. Not when you're using positive bases. Okay. Yes, 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 yes. Yes, yes, yes. 14 of you are right. 15. 16. I'm still waiting for about 6 more people. 17, 18, 19 of you are right. Got glare. Can you tilt it? You got another glare one. I can't read yours. Yes, that's right. Now I can see it perfectly. It's amazing how just a little turn of the iPad. All right, this one. Square root of 16, 4. What's that mean? Flip it. 1 over 4. All right, let me give you another one like that. See if you can handle this one. Think of it as two parts. There's the squaring and there's the flipping. Sir. Yes, sir. You didn't square. You squared one of them. You didn't square both. Yes, yes, yes. I can't see the bottom of it because you thought, there we go, good. Yep, 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 yep. You squared one of them, and the other one you put to the 4th power. You want only squaring on both of them. Yes, 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 yes. Did you? You get 2 different answers there. Oh, that one. Yes. Okay. So first the squaring. 9. Oh wait, I'm flipping and squaring. I don't want to do that. Square it first. 4 9ths, and then what part have I already done? The squaring. What's left? The flipping. So then the final answer is That to the negative 1 is 9/4. There we go. So I did two parts. I did the squaring and the flipping. You probably did it all at once. But okay, I think you're catching on to this. So what if I had 1/4? What's that the same as? There's two options. Would you agree that would be 4 to the something? 4 to the what? Negative 1. Or you could replace that 4 with a 2, and then you would say it was 2 to the negative 2. Do you get how both of those work? Because this one you'd square it first, makes 4, and then you'd flip it, makes it 1/4. All right, so let's do one like that one. 1/81. Several ways you could write that one. 81 to the negative 1 is one of them. I want you to write me at least 2 ways. At least 2 ways you could get this one. I'll give you one of them. That's right. Yes. Yes. You give me 3 ways. Nice. Yes. Yes. The power is wrong on your 9. Yes. 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 All right. Nice. Yes. You got 3 ways there. And yes, but it's different than everybody else's. Let me just show you what I was expecting you to say. You were going to go, okay, 81 to the negative 1 works, and then what is 81 actually? 9 squared, but I still need the negative, right? 9 to the negative 2. And then some people went as far as to say, okay, well, this 9 could really be like 3 squared, right? So then I could rewrite that 9 as 3 squared to the negative 2, which is really like 3 to the what? Negative 4. Nice. So this works, and this works, and this is kind of like a math problem, but that works. Okay. We need to step aside for a second to be able to see that, because now when I say 1/81, you can go, oh, yeah, that's 9 to the negative 2nd. Okay? So let's go back to one of these problems. Ooh, look at that. 1/9. What's that the same as? 9 to the negative 1, or what if we wanted to make it based on a 3? Because see, if we make these both based on a 3, then the bases will be the same. Don't give me the final answer. You're going too fast. I'm glad you can go that fast. But just tell me, you could replace that 1/9 with a 3 to the what? Negative 2. And it's to the x. Equals, and I can replace the 27 with a what? To the what? 3 to the 3rd. There we go. Now, if this part I think is easy for you. I hope it's easy for you. This part might have been harder, but we just did this a second ago. 1/9 is the same as you take the 3 and you'd square it and flip it, and you'd get that. What's really important that you get when you're solving these is that these have to equal. If I have 27 here, this has to equal 27. You'll be tempted to just do stuff like, I'm going to square it. You can't just square something. You have to make it the same. This has to equal this. To do a substitution, they have to equal each other. All right. So let's do another one. This one. Make them both have a base of 2. That could be a 2 to the something. And this could be a 2 to the something. You got to figure out what my blue question marks are. Once you have them, it'll be easy to solve it the rest of the way. Yes, yes, 2 people have caught on to this really well. Good. Now, can you actually solve it the rest of the way? Yes, yes, yes. Something went wrong on your answer. I can't tell where the mistake was. Yes? I really, honestly, yes. If you get things wrong, yes. It's not a bad sign. You just made sure that you don't make that mistake on your homework, because you'll look back at it now and see what you did wrong. Yep, that's right, and that's right. Thomas Edison. Yep, yep. His quote that I had on the wall there for a long time said that people usually work right up until the moment when it gets hard and then they quit. And he said that is the moment where you're just about to break through and get the answer. This is the guy who tried 1,000 different things before he discovered the light bulb. He tried it 1,000 times, literally.
I had a great quote about that.
Has he? Go ahead.
I didn't fail. I found 1,000 ways how not to make a light bulb.
Yes, I'm going to repeat that for the video. He said, I didn't fail every time. I was finding ways that didn't work. I found 1,000 ways to not make a light bulb, yes. So anyway, the point is, you really, if you're making a mistake, I really want to value that in here. It's the people that don't try that are failing. The people that try and fail have found a way that doesn't work, and that's good. You now know not to do it that way. That's a good thing. Okay, so I hope you change this 1/4 to a 2 to the, well, I do it one step at a time. 2 to the second makes it 4, and now I'm close, but I need it to flip also 2 to the negative second. Okay? This one, the 1/2, to make this 2 like that, all I have to do is flip it, right? So this question mark just needs to be the flip it thing, which is what? -1. Final answer, that times there equals that. So these two multiplied makes -2x equals -2, and then I divide both sides by -2, x equals 1. Okay, some of you haven't been showing me, it makes me nervous that you're struggling. Maybe you are, and I'll come out there and help you with that in a minute when we have some work time. All right, this one stumped me last hour. Like I screwed this one up badly last hour. I figured out what I did. I just did one little thing wrong. And you know what I did? I broke that rule. When I substituted in, I made something not the same. These have to be equal to each other. This is to the x and this is to the third. I have to make this equal to whatever I put in here. And I have to make this equal to whatever I put in there. They have to be the same thing. Okay. See if you can find the combo that works so that the bases will be the same. I'll give you a hint. Your base on this is not a 2. It's not a 5. It's not a single number. It's a fraction base. You found it. Good job. So what I really am looking for is you rewriting this thing with two fractions that are the same as each other, the same base. You got it. Good job. That's not the right final answer. I can't tell what your work was, so I can't tell if you did it, what you did wrong. Can you zoom in on it? You did it right. Nice job. That was a hard one. You beat me. Something went wrong. You know one way not to do it. Yes, that's what I was looking for. Yes. I'm thinking you're on the right track. Yep, and if you can just solve that, you'll have your answer. You might have one negative off in there, so just be careful. All right, I know a lot of people are stuck. Hey, I was stuck on this one. So would you agree that if your answer has to be a fraction, we might as well have that fraction be 5 over 2? I mean, it's either 2 over 5 or 5 over 2. Okay, maybe you don't understand why, but these numbers right here can be turned into a 2 and a 5 fairly easy, right? How can I get these guys to turn into a 2 and a 5? I can take their square root. Option B, some people do it this way. Some people make them both use 4 over 25. They leave this one alone and say 4 over 25 is my base. Couldn't I rewrite 5 over 2 as a 4 over 25? I could. All right. I think the easiest way, though, is to make them both into a base of 5 over 2. Now, what's wrong with this picture? This is where I made my mistake last time. What did I just do wrong? Yes? Exactly. On the right side, these are not equal to each other. These are equal to each other, so I'm fine here. I need this to be to a power so that it will be true. 5 over 2 to the what would make this equal? Negative and 2. Negative 2. Why should this be to the negative 2 power? There's two parts. We need to square them, and we need to flip them. All right, now that they have the same base, it's easy from there. That equals that. X equals negative 6. Done. All right. That was a tough one, I know. Okay. This one is only complicated because its exponent looks complicated. We have never been messing with the exponents, like this part, until the end of the problem. So don't worry about it until the end of the problem. Make the bases the same. It should be pretty easy to make this 1/2 into something else. And it should be pretty easy to make this 8 into something else. All right, looks like you used a base of 2 on both sides. So how many of you are using a base of 2 on both sides? Good. And you're on the right track. And again, I have to find something for the power here and here that makes these true. 1/2 is really 2 to the negative 1. Hey, I got that side done. That was easy. And 2 to the what is equal to 8?
3.
Yep, 2 to the 3rd. See, this equals that. If you get them to equal each other like that, that's what's powerful. And then, if these two are the same, then this has to equal this. You have to multiply it all out. Here's a really common screw up. When people are multiplying this out, do you get how somebody might just go, oh, so I'm going to make the x negative because this is getting times by this. Do you get it actually has to be times by both of them? It's distributive property because there's a minus there. So it's negative x plus 1 equals 3. I'm just doing the green part I circled. Negative 1 has to be times by the x, and negative 1 has to be times by the negative 1. Subtract 1 from both sides. Negative x equals 2. If negative x equals 2, x equals negative 2. And there you have it. Okay, these are tough. These are not, they're not impossible. Some of you caught on to the pattern, and it's like, oh, it's not that big of a deal. You just got to make both sides have the same base. Once you get the same base, it's easy. But to do that, to make both sides have the same base, you have to understand fraction exponents. Last little summary. Some numbers you should know for today. What's 5 to the 3rd? It's going to come up a lot. 125. What is, let me think, the other one, 3 to the 5th? 32. Thanks for trying. It's okay. Oh, wait a minute. Oh, are you right? No, I know what you're thinking of. You're thinking of that 4 to the... No, wait a minute. No, you're thinking of 3 to the 6th, I think.
There's a lot of sleeping involved.
I'm wrong. 3 to the 5th isn't anything. I totally made that up. Okay, 3 to the 5th is something, obviously, but it's close. You were actually closer than I was. What I should have done is 3 to the 4th, and then you would have been right when you said your answer. Say your answer again. 81. Sorry. You don't have to memorize 3 to the 5th. My bad. Okay. So let's actually start your homework together, because I think that gives you some confidence as you walk out that these aren't impossible. And we're only doing evens today because there's very little work time. And it's a math day, which shortens up our school day, or shortens up your class hours anyway. Okay, so look at problem 2 on the worksheet for today. I'm going to pause while I pull that up. All right, so here's our worksheet. It is lesson 2, base change, and this is unit 11. And I'm having my kids do the evens here. So this power has to equal this power because the bases are the same. So 1 minus x has to equal 4, and you just have to, solve from there. No big deal. Subtract 1 from both sides, and that's an easy one. Okay. This one a little harder, because you got to make the bases the same. So 2 to the x, that's got a good base already. And let's make that negative 4 into a, interesting now, you got to be careful with this. Would you agree that 4 can be changed into a 2, but I'd have to leave the negative on it somehow? 2 squared is 4, right? Now, a lot of people would say, but wait a minute, Mr. Server, you can't do that because negative 2 squared is positive 4. No, if I had parentheses here, then I'd be doing it wrong. Because then this would be positive 4, and that's negative 4, and they're supposed to be equal, right? In case you didn't know, negative 2 squared like this means you do the 2 squared first, and then you apply the negative. So this is equal to this. So now I've done it right. So now, if the bases are the same, are the bases truly the same?
No.
Okay. But if the bases aren't the same, then I can't solve. So it says, why can't you solve for x? Well, you might have thought you had it with 2, like x equals 2, right? But it doesn't work. When you put the 2 back in, 2 squared isn't negative 4, is it? But didn't they just set up a problem where you can't make the bases the same? If you can't make the bases the same, you're not going to be able to solve it. And bottom line is, why can't you solve it? You can't make the bases the same. Or another way to say it is, you can't put any number here to make 2 to the something equal negative 4. There's no number to put in there. You can't make something negative by changing its power. All right, so there is no solution. And I hope you can't make bases the same. Okay, number 6. 8 to the 3x equals 16. Okay, so first thought, I would really like to make both of those into having a base of 8. No, because 8 to the something isn't 16, at least not nicely. So I better make them both have a base of 2. Remember what I said about this? I can't just change this to a 2, but I could change it to a 2 to the 4th. I have to make it something that equals 16, right? And I can't just change this 8 to a 2, but I could change the 8 to a 2 to the 3rd. And then I put it to the 3x. And then the bases are the same, and that's 3 times 3x is equal to 4. 9x equals 4, and you can solve from there. It should be easy. All right, hoping you're getting the idea here. And I want you to finish the evens on that worksheet, and that's all I have for you for today.